Okay, hello everyone. I will try to keep a talk about Cloudera Director and telling you how to run Hadoop in the cloud. And yeah, so first a few words about me. I'm a COE, so Customer Operation Engineer at Cloudera Budapest. I'm a software engineer in the past 12 years. I'm very enthusiastic about distributed computing, Scala, functional programming, and things like that. So mainly that's about me. But the interesting stuff is step 0. What is this Hadoop stuff? So please hands up. Who does know what is Hadoop and what is it about? Okay, great. That's much more than I expected. So for those who did not touch this term yet, Hadoop is a platform for big data. And so just to give you a brief overview about this, the spine of the Hadoop platform is the HDFS. This is the Hadoop distributed file system where we load the data, your existing big data, into this HDFS. This is a cluster-based solution, and on this HDFS we can perform very different calculations on your data. The very basic example is the MapReduce. Please again, hands up. Who doesn't know what is MapReduce about? Okay, a bit less. So MapReduce is coming from Google. They released a blueprint about a paper about this since a decade now, where they define that by time, if the data grows, it will be more and more difficult and challenging to move this data. So it would make sense to, instead of moving the data to the calculation itself to process it, because anyway, if we don't do anything with the data, it's just data. So then we cannot extract the information about this. So definitely we would like to do something useful, valuable with our own data. So here's the idea. Instead of moving the data all around, load it into something which can store it in a fault-tolerant and scalable way, and on that storage, move the calculation to the data itself. So MapReduce is a very simple idea. Every MapReduce application has two phases. One is mapping some function on the data, so you can really think about this in a very functional way. You have something, so for example, you would like to transform your data. Maybe you have every drama written by Shakespeare, and you would like to uppercase every word in that. Then your mapping function is that, okay, if I've got something input, I'm generating that output in an uppercase way, and that's it. So this is the map phase, and these map phases generating so-called intermediate results. And in the reduce function, we collecting these intermediate results and combining them in such a way. And Hadoop, together with the HDFS and MapReduce, is a platform for this. Okay, and of course, on the top, we have lots of different other kinds of applications. So we have NoSQL database built on the top of HDFS and Hadoop. We have Spark, which also can leverage from HDFS and Hadoop kind of computation and things like that. Okay, so yeah, this is Hadoop. And why is it important for us? Because we are Cloudera. We are a Hadoop vendor. How can we be a Hadoop vendor? You could ask, because all of this stuff is open source. So first of all, one of our chief architects, Doug Ketting, is the main creator of Hadoop. So we have Hadoop as our own knowledge, and we have lots of developers all over the world who actively and mainly developing different components, including Impala, Hive, HDFS, Yarn, and things like that. And meanwhile, we also got our own enterprise cluster for Hadoop called CDH. And bound together with the CDH, we also get an ingenious application called Cloudera Manager and Cloudera Navigator. So we can ship you freely a very mature platform where you can easily stack and link together these open source components, and you don't have to struggle learning each component's configuration and learn how does these components work together. And of course, this is our main business model, that we are shipping these softwares in a very open source and free way. And next to this, we selling to our customers our knowledge through technical support, through solution architects who goes to the companies and try to solve every kind of issues, what can appear at the customer, learn their own business and help them to build their own cluster and things like that. So this is the Cloudera Enterprise, and next to the Hadoop, we also get a platform. And this is relevant for us because by default, it is shipped on cheap commodity hardware. Okay, now I used to get the question, okay, what do I mean by cheap? And by cheap here I mean, yeah, so for example, for a starter company or for a single developer, it could be very expensive because here the boxes usually cost, according to our recommendation, each node costs $6,000. It sounds expensive, but if you think about that you would buy an Oracle cluster or a Sun cluster back in that time when they did exist, or things like that. So real big platforms and real big clusters cost much more. And so the reason why do we advise to buy commodity cheap hardware and using it like this, because as we're going for big data, we would like to scale out horizontally, really. So we do not need strong machines. We do not need very fast performing. So we don't go for HPC. We don't go for lightning fast storage disk. We're just going for average processor, average disk, because definitely we would like to scale out our problem with the number of the nodes, you see. So we're really going for distributed computation. But again, then you could have the next question that, okay, but if it is the bare metal hardware, okay, but where is virtualization? So this is VDAY2015. Why am I telling you this? Yeah, absolutely valid question, and here is the answer in this presentation. But first, to know the answer, first we have to answer the questions or the use cases. What justifies to run Hadoop on different cloud platforms, or justifies the usage of cloud vendors for Hadoop? And we can identify, of course, there could be more or even much more, but we identified these as the main reasons why you should consider using Hadoop on the cloud. First of all, deployment. So if you wouldn't like to struggle with deployment, you like instant solutions, or you like to clone your own existing solutions. This could be achieved easily in a cloud environment. So for example, just imagine if you have bare metal hardware, so commodity hardware built Hadoop cluster from, what to say, 2,000 machine nodes. And for example, your boss telling you, okay, we should try to use this cluster, but in a bit different way, and we should test it before we will buy the existing hardware, because it is a node, it's inexpensive. So then it would be tricky and very risky for you to reconfigure your existing cluster. But with the cloud-based solution, then it's just a few additional clicks for you, cloning that cluster and trying it in a very different way. Okay, and of course, any kind of support for elasticity. Meanwhile, it could be also important manageability. So usually, if you go for a cloud vendor like Azure or AWS and things like that, you get lots of manageability tools out of the box. They give you dashboard, they give you templates, they give you lots of monitoring tools, and this could be very useful if you are not experienced in this, or just you wouldn't like to develop this stuff, because it takes time, and time is money. And of course, it could be also very important to integrate it with the existing open APIs, and this is also shipped by the cloud vendors. And the fourth topic is enterprise. So by design, by default, on these vendors, you have those standard enterprise stuff that is needed if your data is very confidential, for example. So you have built-in security, you have built-in encryption, you can easily turn on high availability, fault tolerance, and things like that. So this could come also out of the box. So make it very flexible to use this kind of stuff. And from these topics, I would like to highlight another one, because for me these are the most important. That so having an infrastructure nearly instantly, immediately have storage, processing, analyzing, and visualizing the big data, and the scaling, so the elasticity. And a couple of minutes ago, I had a conversation with one of my friends, and they got a new company, and he told me they could consider later to use Hadoop. Yeah, it could also validate to use Hadoop on cluster, a cloud environment first, because if you have a startup or just a little company, or for example, if you have a pharmaceutical company where you have your own drug discovery developers, but for example, you don't have IT engineering, it's much easier to you to deliver your Hadoop-based solution in the cloud, because then you don't have to play with the bare metal hardware, with the network infrastructure. You don't have to hire, for example, 10 infrastructure IT guy who doing the real stuff. So it could also validate all this stuff. Okay, so now we understand why we would like to run Hadoop on the cloud, and an addition for this is that we have existing examples. So in this big data transforming business, we already know serious companies who are delivering Hadoop-based solutions over the cloud. So existing things also can validate this whole stuff. And for example, Airbnb uses Cloudera, the CDH platform, on AWS for their machine learning algorithms, to supply the data in their machine learning algorithms, and thus they can advise the rental properties for the clients in a much more effective way. Okay, another example. We also know about a Khmer company who uses Cloudera, Cloudera's big data solution to do the big data analytic workload so ahead of the competition. So yeah, I think it's impressive, and the most impressive, I think, the third example, that FINRA uses us together with AWS to process 30 billions. It's a lot. 30 billions market events per day. They can, so they know everything about the US market, what they would like to know actively, still saving 10 to 20 million bucks a year by not having their own hardware infrastructure. So you could also validate this. Okay, so now we know what Hadoop is. We know why we would like to use it not on the bare metal hardware, not on the commodity hardware, but instead of on cloud. But we should also consider how does it differ from, so the both solutions from each other. And So Hadoop is different in the cloud because on the on-premise we have, of course, direct attached storage because we store the data on the disk. We cannot share easily data across different clusters. So, of course, for example, if you build a cluster in the US from 2,000 machines, and if you build, for example, 5,000 machines in India and another 4,000 machines in Europe, these are single different clusters. So you cannot easily, or even do not can, share your existing data between these clusters. Of course, the size is fixed. It could be good because then you can count with the computing performance and the storage what you have. But meanwhile, all users have to share the very same cluster. So in that case, you have to care about scheduling and things like that. And of course, Cloudera has the solution for this. So for example, we have a quite good working and quite new first scheduler which handles the jobs in a very effective way. But still, sometimes you would need much more flexibility. And this is what you can get through the cloud, because you could have direct attached storage, but meanwhile you can also have very fantastic object store. So you let your cloud vendor to store your data, and you can easily out of the box pull the data out from this object store what they have. And of course, by having this, you can easily share your data among the different clusters. And yeah, dynamism, I already mentioned this. So if you are not sure about what kind of calculation you would like to achieve, very often makes sense to play with the number of nodes in a dynamic way. And as for this, any kind of elastic solution is more than awesome. So just to give you a concrete example, it used to happen that even data scientists try to implement the new machine learning algorithms or just feeding them with more data, and they struck for 1 or 2 weeks or even months until they can design the real good architecture, the appropriate number of the nodes, the appropriate number of disks, and things like that to let it work effectively. In a dynamic ecosystem, it helps you to play with it much faster. Okay. Okay. So common architectural patterns in the cloud, what we identified so far in our work. So there are this stuff, ETL, modeling, and things like that, where you have nearly little local storage or nearly no local storage in your computation nodes. Usually these clusters are short-running clusters, having elastic workload. Good examples here, MapReduce applications and, for example, Spark applications. So this is about, yeah, I have a bunch of data, I would like to calculate something, having the result, but fire and forget, even the program itself. So maybe extract every relevant data from the selling during the Christmas. Yeah, I've got log files, I extracted the data, maybe I can later throw away the data itself. Never do this, believe me, later you will need it. But so you see, this kind of application is about, yeah, written an application, run it once time, write it down the results, that's it. End of the story. A bit different is the business intelligence and analytics-like solutions. So text data, Solar and Lucene and Kafka and these library-based text search algorithms. So these are long-range clusters. Maybe having some local storage, maybe not. But so this is about really seeding data. The first it was about sourcing data. And of course, we could also have app delivery where we doing this backup-based stuff. Even, for example, with HBase, so having a NoSQL database built on the HDFS itself, and of course, in this case, you need lots of storage on your nodes itself because you store the data there. So as you can see, the usage of Hadoop ecosystem can vary very much. And for this, you need this flexibility. Or even if you don't need, it can be handy or useful sometimes. Okay, but then you can have the question, okay, so how should we deploy Hadoop on the cloud? And here is the solution, what do we have for you? And this is Cloudera Director. By the way, this is a sentence from one of my favorite cartoon actors called Super Cow. Super Cow always came for rescue. So Cloudera Directory is the software what will save us. What is this Cloudera Director? This is a web-based application. You can easily download it from cloudera.com/download. This is a free application. I'd like to highlight here that nearly all of our products open source, but Cloudera Director is not open source. And as far as I know, I just talked with developers a few days ago, they do not plan to ever open source it, but we still have our hope about extending it, so don't lose your hope. But so just to highlight, maybe this is one of our very, maybe now the only single component which is not open source in our ecosystem. So with the help of this, so you can download it, you can install it. It is a server application. It has a very fancy web interface, and through this web interface, I will show it in 1 or 2 minutes because I will run out of the time. So through this web interface, you can easily fire up already trusted and production-ready applications. So you can fire up the very same Hadoop cluster, what you can use it, or if you not use it, the very safe and mature Cloudera-based solution. Because, for example, you could ask me, okay, you have this Cloudera Director, yeah, you are telling me that this is flexible, fancy, and simple, the administration and things like that, but we also know that AWS have Elastic instances shipped with Hadoop. Why should I use Cloudera Director instead? And here is the answer. Cloudera Director will give you the very same setup what would you install with Cloudera Manager and CDH platform. So you can even buy the very same support, the very same solution architect, and everything else for these environments as well. So doing it in a virtual way doesn't mean that you have to make any kind of modification. In your ecosystem, you have the very same software components. That's the biggest benefit of Cloudera Director, that it ships you the very same CDH platform. And okay, so one example about cluster, I already touched this topic a bit. So you have an already working workgroup, but those instances are disk optimized, and now you have to try or make a different solution which is memory optimized. Then you can easily say, you choose, for example, the template of workgroup 1, modify it a bit, change the instances under it, and deliver it with memory optimized instances, because, for example, you would like to run Spark applications or Spark calculations on the cluster itself. And of course, with the help of Cloudera Director, you have all the flexibility. So you can extend in a very flexible way your existing clusters. You can use Cloudera Director to manage any kind of configuration. You can even manage the security curvers and everything else. Okay, so because I still have, I think, 4 minutes, of course I wouldn't like to steal your lunchtime, because that would be a crime against you. So one word about extensibility. We have this SPI interface bound to Cloudera Director. So still, the application is not open source. We have an open API. And you could build your own service provider for existing cloud if it does not exist. Of course, we have service provider interface for AWS, we have it for Azure, but if, for example, you have a private cloud built on your own or your private version of the system, you can connect it together easily with Cloudera Director, just implementing this one SPI and end of the story. Everything else works out of the box. Okay, and now I have time only for show a few screenshots of about the application. So here is the login page, but this is not interesting. This is the more interesting. So setting up a cloud-based Hadoop system, a cloud-based CDA system with Cloudera Director has all these 3 steps. First, we have to set up an environment. Then we have to add the Cloudera Manager because, you know, from the Cloudera Manager, this is the entry point for our Cloudera cluster. And after that, we need to define our own cluster. How many name nodes do we would like to have? How many master nodes? Things like that. So doing this is very easily. So first, it's quite the very same workflow what you would do, for example, in the Amazon web page. First, you define your environment, choose your template, creating the instance, and yeah, we are fine. Okay, for one of the instances, we are adding the Cloudera Manager. Here we can see that we are already having this instance template. As I already told you, this instance could be varied, so it can contain more disk, or more memory, or very fast storage, or things like that. So it's just your own decision what kind of cluster you would like to build. And after that, you add your own cluster. You can define what kind of CDH version would you like to choose, which services would you like to deploy. So for example, this screenshot was about deploying core Hadoop together with Spark on Yarn, so this will be MapReduce 2. We are using the same instances for the master nodes and the worker nodes. And for example, in this example, we use 1 master node and 3 worker nodes. But as you can see, from this point, it depends only you. You could even use it here 1,000 or 10,000 nodes. And this comes for you out of the box through Cloudera Director and through your cloud vendor, of course. And after this, it takes only a few seconds. Really, we have a very fast video about this live video on the Cloudera Director website. If you have time, check it. So it needs not more than 4 minutes to set up a fully working cluster. And as I already told you, you can also modify your own cluster. You have lots of API console connected to it. You can even check the as, query the different states of the cluster, and I think that's it. Thank you very much for your attention. Again, once more, I'd like to apologize for the technical difficulties, and if you have any questions, I'm very glad to answer.